This is a foldable for section 6.3, testing parallelograms. What we're doing in this section is determining whether a quadrilateral is a parallelogram. I went ahead and I filled it in, so if I'm going a little bit too fast for you, just please pause the video. The first way that we're going to look at determining whether ABCD is a parallelogram is by using the slope formula. It has to have opposite side have the same slope, and here's the slope formula. If we take a look inside, I have graphed the points, and then I did the slope formula for BC and AD, and see that they're the same. Then I did the slope formula for AB and CD and see that they're the same. Just to remind you of how we do the slope formula though, is if we're looking at BC, we do the y's first, so 3 minus 3 is the numerator. And then the x's go in the bottom, 5 minus 1 is the denominator. Once you have the numerator and the denominator, you do the operation. So 3 minus 3 is 0. 5 minus 1 is 4. Then you simplify your fraction. 0 divided by 4 is 0. If its opposite sides have the same slope, so you have to check all four sides, and opposite sides are supposed to have the same slope. Therefore, you can prove that ABCD is a parallelogram. The other way we can do it is by the distance formula. I have written the distance formula right here. And what we're looking for is something similar where the opposite sides have to have the same distance. You could call it length, but they mean the same thing. Let's take a look inside. So we find the distance of all the sides, but proving it, how you have to have all the sides and opposite sides are supposed to be equal. But to disprove it, you just need one pair of sides that doesn't work. So for example, I found the distance of AB and the distance of DC. And they're not the same. Therefore, the quadrilateral ABCD is not a parallelogram. Let's say that they were, then I would have to check the other pair of sides with the distance formula as well. Let's take a closer look of how we're supposed to do the distance formula. And let's do AB. First, we're supposed to have the x values. So it's supposed to be 3 minus negative 1. Squared is part of the formula, plus the y values, 0 minus 0 squared. Then 3 minus 1 is 4. We still have to square it. 0 minus 0 is 0, and we still have to square it. 4 squared is 16, and 0 squared is 0, and so that's the square root of 16. You can simplify this and say that it's 4, but it's not necessary. This is enough to show whether this is equal or not. Okay, and then the other method to determine whether ABCD is a parallelogram is by using the slope and distance formula. One pair of sides has to have the same slope and distance. So if we do this method, we're supposed to do the slope for AB and DC. So as you can tell, I was on my way of doing that. We know how to derive for the slope. 2 minus 3 is 1. Simplifies to negative 1. Simplifies to negative 5. So they have the same slope. Now we need to check the distance. So I'm going to write the distance of AB is equal to the square root. Just to make sure that you understand how to do the distance formula. We do the x's first. Negative 1 minus negative 2 squared plus negative 1 minus 4 squared. Minus is part of the distance formula. The square root. This becomes 1 squared plus negative 5 squared. which equals 1 plus 25. That's the square root of 26. You also have to check the distance between DC. We do the x's first. So 2 minus 3 squared plus, and then the y's, 1 minus negative 4 squared. That's negative 1 squared plus 5 squared, which equals the square root of 1 plus 25, which is the square root of 26. So since one pair of sides has the same slope and the same distance, we can conclude that therefore A, B, C, D is a parallelogram. This one you might be able to tell that it's clearly not a parallelogram, but I don't want you to say that first. I want you to be able to prove it. So the last method that we have to determine whether ABCD is a parallelogram is by using the midpoint formula. Just to remind you, it's this right here. We take the average of the x's and divide by the average of the x's and the averages of the y's. And they have to be the same. So the midpoint of the diagonals is the same. So we're looking for the midpoint of the diagonals. Here I graphed the points, and then I made dash line for the diagonals. And what we're supposed to see is that the intersection between them should be the midpoint. But you can clearly tell that it's not. How we determine that is that the midpoints have to be equal. So let's take a closer look of how to do the distance formula. We're going to do DBD, because that's the diagonal. So you do the midpoint formula of the diagonal. You do the x's first, and we're adding them together. So we could say 1 plus negative 1 divided by 2. And then the y values, 2 plus 4, and then divided by 2. So on this one, we're adding them together. That's 0 in the numerator, still divided by 2. 6 in the numerator, still divided by 2. 0 divided by 2 is 0. 6 divided by 2 is 3. So I did the same thing for AC, but as you can tell, it is not the same. Therefore, ABCD is not a parallelogram.